Hey, welcome to the It's All Good mining channel. Man, let me tell you, mining and repair channel, that's where we are. I am having a bad computer day. I'm sorry for um, the inevitable problems that I know we're going to have. But let's just dive into this. Um, this is the board from hell. It's not that bad, honestly. I shouldn't complain. Man. All right. Guess I'm gonna have to switch by hand today. This will be fun. I did try to adjust the camera angle of my overhead, so hopefully we'll be able to see a little bit better. Um, Let me just make a couple of camera adjustments. I've been trying to make things better all for the past hour. Okay, I think that's better. Cool. Yeah. All right. There we go. So this is the board. Now, this is the board I've been working on, and if I go over here to my team miner view, nothing works. There we go. My team miner view. Then I see what's going on with my. Okay, crazy things going on here today. Looks like my camera's out of focus. All right, we're going to keep moving because I just want to work on this board. This YouTube channel's getting in the way of me fixing a board. So let's. I've got a new thing I've been working on, and what it is it is a thermal camera. Now, I'm using the FLIR. I think it's called the FLIR Gen 1 or Gen 3 FLIR 1, something like that. I got mixed emotions about this thing. What I did figure out, though, is that if there's an adjustable part right here that makes the USB go in and out, and that's really nice because when you have that feature working, you don't have to take your phone out of the case. They make the model for this that works on, there's one model for Androids, and there's another model for the iPhone. So if you like what you see and you want to go get one, go on Amazon. It's called the FLIR 1 USB-C. I'm not going to put a link in the comments below because I don't think it's worth the $300 and some odd dollars that you spend on it. If I didn't have it, I probably wouldn't. I wouldn't buy it today. That being said, let's get connected here. Let me turn it on. I truly never know what it's going to do because it just has a mind of its own. Because I want to show you something really important. There we go. All right, so now let's see if I can. Oh, there we go. Hey, something's working for me. So this is my thermal cam, right? It effectively is a little bit more than a box on my screen. And it, just like you saw there, it freezes. But it can show us something, and that's what I want to get into. So let's go ahead now. I'm going to put myself in temperature test mode. 65A6, here we go. We're heating up. Now, there's a little bit of an alignment issue with the hot spots, right? They're not perfectly over the chips. This is one of my complaints. But if you see, there's a few spots that we have a lot of heat. Now, one of the spots we have heat is right next to 15. Now, chip 15 right here. That's where we're getting the most. That's where the hottest part of the board is right now. And as you can see on the screen, it says 56 degrees is what the temperature sensor on the board is reading. Now 58. Okay, so that's down there by 15 on our test port. All right, so there's a spot right next to it, and it's going to get hot until it gets over 70, and then it'll just disappear. and it'll cool off. So there's some kind of hot spot going on there. There's also this hot spot right here. Now this is chip 19. I replaced this chip. Why is this chip running so hot? How hot is this chip, you ask? Well, it's a little thermal cam says like 54, 55 degrees. That's crazy. So there's a hotspot problem with 19. And then if I keep looking, I have a hotspot issue over here by 35. But that looks like it's in the board, not on the chip, right? Because it's reading 60 degrees right around 35. So I think we have a problem on the back side of the board. And then where else do we have a hotspot problem? Right here, maybe? All right, so that's right around 52. That's right in this area. So I'm not sure about that one, but I think that there is definitely a hotspot somewhere around 52. All right, 52. Okay. Ooh, and then we know we got something around 35. So there we go. Yeah, see, that's crazy hot. Okay, I'm gonna turn it off because we're getting some really warm temperatures. My goodness. Look at that. Even after I've turned it off, look at how much heat we've got in the board around 19. The weird part is it's not really... I feel like if it was really hot, it would be burning my finger, right? But, okay, so now we're down to 42°C. So maybe crazy amount of heat though in that general area. Same thing here, crazy amount of heat. Thermal cam to me is kind of fun because it gives us another way to test things. All right, let me turn that off. We'll bring that back after a while, maybe. All right, so what was the other thing I discovered? Well, I discovered this really nice... I discovered this really nice trick, and let me see if I can find a layout that's going to be better. Well, that's a terrible... Okay, so if you want to know just how messy my room is, right? What's off camera? There you go. All right. So let's see. Will this work? Yeah, sure, this will work. Let me show you what I found out about testing last night, and we'll go from there. All right, so what I discovered in my testing last night is a better way to check the... There's a better way to check out the... looking for bad chips that are outside of range. And one of the things that I noticed, or one way I was testing chips is I was taking my positive lead, putting it on the top of the chip, and then I was testing all 5 points with the diode mode. Okay, that's fun. Right now I'm in voltage mode, and I'm actually getting values. That's fun. So here's how that would work. Set to diode mode, turn the beeper off. It'll look 1.278, 1.22, 51. Okay, so these are pretty normal values. Wait a minute, that one wasn't. Okay, but I found something that works a lot faster for testing chips that are already installed on the board when you're hunting for a problem. What I found is that I can flip over to resistance mode instead of diode mode. I can put my negative on the negative side of the domain. Okay, so with these chips, this would be this side of the chip. Okay, so I can put my my tester or my negative there, and then I can just measure resistance. And as long as the ideally this is not a great example, but with 189 is not bad, as we saw. So we can let's check that. So 189 ohms, and if we flip back over to the diode mode, and I quickly check, the values are pretty close. Okay, they're not way out of whack for diode mode. So that tells me this chip's probably okay. So it's just a quick way that I have found to check the values of the chip. In resistance mode, you're checking one value versus having to check 5 on this side, 5 on that side. So I found this to be very quick because I could go through my chips and see what's going on. So what I started doing last night is anything, I just went with the highest ones. I had some that were like 700 ohms. I just started replacing anything because what I found is the 700 ohms was out of spec, right? I mean, when I checked the diodes, it was out of value. Now, this is a great example of a chip I probably ought to replace. Let's find out. Let's flip this chip. So 233, is that the threshold? What's the threshold? I wonder. What's the threshold? Kind of know what values I should be looking at. Oh. Diode mode. 299 or 1.29, 1.8 or 1.1, 4.7 or 0.47, 0.29. Okay, see, so there we go. Okay, we're right on the tip. You really don't, you want to see 1.2. If you see 1.3, you're really getting outside of a good chip. See? So this is probably a weak chip. Because we can find this two ways. I can go to every one of these and I kind of know that the BI, which is this point there, should be 1.2. Okay? The RSTI or RST should be 1.1. Should be below 1.2. The RO should be in the 0.4 range. This one, which is the CI, should be 1.2. And the clock should be 1.2. So I found a bad chip, but I had to do all this testing to figure it out when I could just come over here to resistance mode, put it on. Oh, sorry, wrong chip. I moved my. I could just put it in a resistance mode and say, oh, wait a minute, that's above one. That's above 200. So this is a bad chip. How fast is that, right? So if I put an R on there for resistance, let's do the rest of these real quick. Now, what was that one that was hot? 19, right? So I'm gonna go to 19. Now this has an okay that because I just tested this, or I just replaced this chip. So resistance wise, this is a good chip. Okay. Oh, look at that, 20. 20's not so good chip. Now, funny thing about 20 is that 20, when we did when I put the thermal cam on, 20 was showing like ice cold, like it wasn't even coming on. So maybe we need to replace 20. My point being is that I think we have a bunch of chips that are out of sorts. That are way out of spec, and because they're out of spec, they're causing these signal problems. Right there. So 11. See how much faster this is than testing? Huh, that's interesting. We've got a high ohm, or we got a high resistance chip right around the spot where we've got a heat problem. So now, what do you do when you get to here, right? Because there's no shiny little silver spots. So what do? Well, you can come to the back side of the capacitors where the 1.8 volt and the 0.8 volt are. Okay. So 211. Let's check 211 real quick. Let's check and see the diode values, right, for 211. Is that out of spec? I can tell you that's too low, because that should be 1.2. This should be 1.1. What? What kind of crack is this thing smoking? Okay, this is clearly a bad chip. We have some values that are way, okay, there you go. So there's a value way out of whack. So we just found, instead of having to go through this very slow and tedious process, we just found a chip that probably definitely most likely needs replacing. Why does it need replacing? Because that's crazy. That should be 1.2. So anyway, replace this chip. So that was 211, right? Let's go back. $210, $211. Ah, so really we're somewhere around that 200 ohm, maybe 190, somewhere in there. That's that threshold. You cross it, you declare the chip bad, and you send it out to pasture. There's another one, 230. Resistance. Sorry, I'm off screen. I replaced this chip way back. Okay, so this chip has a. Oh, sorry, I may have been. Go to this one. There you go. I was testing on the wrong side. I was testing on the actual 1.8 volt side. Okay, so that chip's good. Okay. Let's see, where are we? So far, we've got 1, 2, 3, 4 chips, 5 chips that got to be replaced. Honestly, I did not do this ahead of time. I mean, I was working on some of this last night, but I was replacing the lower or the higher values, trying to get to just getting things working. All right, let's keep going. We're going to get them all tested. Okay, 200. Yeah. That's 34. Did we have a heat problem around there? I think so. So let me point something out. So this is all connected. So I can go from here. Okay, I'm just touching the trace that's through the screw hole. I can go all the way up to here. 0 ohms, right? So when I'm testing these chips, it doesn't matter where I put my negative probe for the domain. So I guess get a test point for that domain. I leave my test probe there. All right, I'm gonna go ahead and put this one as R. What at? Oh no! Oh, Mr. Bill. Okay, here we go. 230. Wow, another R. Ouch. $150. Cool. Can't move to this one because if I see, I get all kinds of weird reading. Not necessarily what I want. Maybe it's the same value. Let's see. Same value. Interesting. Hang on a second. Okay. Okay. Huh. Oh, there we go. Okay. Okay. So far, so good, right? So we just got, I don't know yet. Oh, look at that one. Hey, interesting. 52 is one of the ones that had some problems with. PI has an issue here. Yeah. Heat has an issue here. Hmm. Oh, how did that one get looked over? That is crazy. What's going on here? Okay. You saw the OK on there. That meant that this was a replaced chip. That's another one. What's going on? Man, okay. I wonder if that was like a previously replaced back. My testing and all evolves, right? So maybe that was it. Okay, so they're 65. Now, when the last chip is iffy, you can have all kinds of craziness in the world. On a hash board. Okay. There we go. So what do we have? I'm gonna write oh boy. Okay, so what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can't tell what I wrote there. Just check that one real quick. Okay. 13. 14. I'm pretty sure it's 59. Now, the crazy thing is I replaced that one last night on a hunch. Yep. 15, 16, 17. So I got 17 out of 65 chips that need to be replaced. Now, if I'm buying them used and they're about $2, we'll say, a piece, but there's a 50% failure rate, so really it's about $4 a piece. So 17 times 4 is $68. So it's $68 in parts, I think, to repair this board. Hang on just a second. The delivery man is knocking at my door. I think it's a big shipment. I just want to get it inside. Give me just a second. I'll be right back. Let me see if I can switch over to the be right back. Okay, welcome back. Let's see if I can get my computer to work again. Yay, it works okay. So, my apologies for the loud music. I didn't realize that I had it quite turned up quite that loud. I fixed it. Well, hopefully it won't be a problem going forward. So, yep. The package delivery was so large that literally when I opened up the door, you really couldn't get outside. Kind of like those pictures you see with the snow blocking the door. That's kind of how it was, but it was cardboard. It wasn't snow. If it was snow down in this part of Texas, then we'd have a problem. All right, let's see. Which one do we want to dive into? There are so many different possible problems here. Well, I mean, like, right, we have so many. Let's go back. I want to see if I can get my FLIR one to connect. This is why I just want a gun, but hold on. A thermal gun. Sorry, I used that word. I know that it'll probably blow up the algorithm. We're probably done for. Okay, anyway. I was not talking about any kind of firearm. YouTube, settle down. All right, so if I turn my thermal imager back on, that's what I meant. I wanted a little pistol style of thermal imager. If you turn this on one more time, I want to just see what it's doing when, now that we know all these chips, right, that need some love, which ones, whoa, that's interesting. Oh, Sorry. This is the power. Without the power, the test doesn't work well. Okay, so C. All right, cool. And we're off to the races. Whoosh. Okay, so definitely that one, which has got an R on it. That is, right? That's 52. All right, so I'm going to just write down the ones I want to hit first. And then this one, which is 19. We are heating up good. Okay, so those are, see, this is what I'm talking about. I want to point this out now. See how 20 is? It's like ice cold, right? But there's something underneath that's warming up. But 20 is cold. It's just weird. Okay. There's a hot spot right here, and so that is 5, 6. We're going to take out 6 next. What's that? Let's see. Do we have a hot spot next to 35? Ooh, we got a resistance problem right there. So let's get that one. That is going to be, let's see, 21, 22, 23, 24. Okay. Interesting. So something has shut down over here because now my temperature on temperature sensor 2, this is over here, just is reading 27. So we have shut down over here something, and yep, you can see. Is it getting cooler? Yes, it is. Ooh, look at that, 70 degrees. Wow. Okay. Probably don't want to just sit here and take a picture of this catching on fire. So let's turn it off. Okay. So let's fix. We got 1, 2, 3, 4 chips that are needing immediate chip replacement. So let's do that, right? All right. Let's get into, let me see here. I think it's overhead mode. There we go. I think that's the one that we're going to work on. Oh, we'll do the microscope cam because we're going to solder. Turn the fan off. All right. I'm going to write down res. That's short for resistance. Okay. Cool. All right. Get this guy back out of the way. Got to be really careful when you're dealing with these heat sinks, because these fins are easy to bend. So, FYI. Okay. I'm going to move this to the edge of the table. And I'm going to that. All right. So we got 6 and 19. So these two, right? Yes. Nope. 19. There we go. Right? I think that. Why did I not write that one? Oh, this was a heat problem. All right. So we're going to go ahead and replace. We're going to go ahead and replace 19 again for heat. Now the crazy part is. Okay. I got a note on 19 that I had a real hard time getting it to lay down flat. So there could be a problem there. And then we're going to do this one because this is 24. Okay. Let's dive in, right? So let's throw the heat on there. Let's get our microscope cam. We are going for that one first, right? 6. Make sure we can see it. Okay, let's go to microscope version. Anytime now. There we go. Very good. Very good. All right. Let me just get it in focus for you guys. Oh, cool. All right. Good. Awesome. Okay. Let's put the heat on it. We'll change a couple of chips here. Let's see. See if we don't get some change. One of the things I want to do before we go too far in this fun-filled journey, I want to go change out chip 2065. Oof, look at the dirtiness there. Okay. All right. Okay. Oh man, I just remembered I need to reach out to the vendor again for the flux that they shipped me. They charged me for five tubes and they only sent me one. Oh man. I do not like vendors that don't have phones, right? If you don't have phone support and you're selling me something, guess if you're Amazon, I get it, but even Amazon, you can talk to a human being. So that is why I am not recommending that flux right now. More importantly, I'm not recommending that vendor. If I find an alternative vendor, I like the performance of the flux. I just don't care for the vendor. Apparently, if you don't, I get it. You're successful. You don't answer phones anymore. All right. Stop complaining, Brian. Let's keep going here. Okay. Cleaned it off. Took off the old flux. Come on. There we go. I don't know what happened, but hey, you gotta be careful. Just FYI, make sure that when you start rolling, cleaning up an area, make sure it's not so hot still that you wipe the resistors off, because then you make extra work for yourself. Cool. Tell you what, let's get it's a day that ends in a Y. Let's get a clean Q-tip. By all means, use clean Q-tips. Okay. Oh, I have one right here. Okay. All right. Let's get. We need solder. All right. This is too funny. So I just cut little pieces of solder off, right? Look at how small that piece of solder is. Right? Come on. Am I going to use it? You bet I'm going to use it. I'll hold it with the tweezers. And then when I can't use it anymore, I'll throw it away. I do like the other flux. It just flows better. Okay. Clean it up. On these, this is the domain that is, to me, the hardest. Once you have the nuts on there, because I'm working with this big tip, right? So if I didn't have the big tip, it probably wouldn't be a big issue. Okay, but I like having the big tip because some of these pads go into the big pad here, and so I have enough heat to just power through. Okay, cool, cool, cool. Throw that off to the side. Save my super little bitty piece of solder there. Don't want to lose that quarter penny worth of solder. Okay, let's get in. Thank goodness I think I have 17 chips left. If not, then we won't get that far today. Okay, I'll go ahead and put out a couple of chips because, all right, I don't want to use fishy chips like that one. Put that off to the side. It's not necessarily bad just for what I'm doing today. Don't want to use that chip. Those are second chance chips, in my opinion. They're chips that maybe are iffy, but right now I want to use. Okay, that's an iffy chip. Oh, I'm just going to be doing this for a second. Let's go overhead, right? Overhead. Come on. There we go. So all I'm doing, I'm just putting out all the chips I plan to use. Okay. This chip has something other than okay, so I'm just going to put it off to the side. I'll find some more chips. Okay. Keep in mind, every time you heat cycle a chip, it affects the chip, right? So while these are okay, they tested okay during cleanup and everything else, they may not actually make it to install. If I put them on the board, maybe maybe that's the last heat cycle and it destroys the chip. So this is one of the downsides to working with secondhand or recycled chips. Flip side is right now these chips are brand new, about $20 a piece. So it's nice if you can get them secondhand for say $2 to $4, assuming that's the actual cost of a good chip, like chip that tested well. At $10 even for a recycled chip, still better than having to pay brand new. But I would prefer $4, $2, $3, not $10. Okay, so those are the iffy chips. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12 chips. Let's get to it. Let's see if these 12 chips will help us out, right? What else am I going to do? I'm going to do, so this is 6. I'm going to write down replace. All right. Go back to microscope cam. There we go. Hey, man, I love it. So what I'm getting on just OBS, if you know anything about OBS, I'm getting an error message on OBS that says WebSockets, and it probably it has something to do with my touch portal application. So that's because that's how I control screens. Why do I do that? Because touch portal is cheaper than Stream Deck, and I have so many. I don't even have all of my scenes and stuff triggered on my touch portal. I think I have like 19 or 20 now, 20 buttons on my screen. So I would need 32 Stream Deck, or I'd need to buy multiple Stream Decks. I had a 15 button Stream Deck, and well, I outgrew it. That's the reason why I don't have it anymore. We need to lay off the caffeine some. I've noticed for the past day or so my soldering technique has been shaky. Okay, let's just let that heat up. Yeah, I just can't get the chip to seat itself properly. Gosh, man, come on. Okay, take a breath. Whew. The weird part is I can't find a place to rest my fingers right now. Okay, while things are hot, need to move that around a little bit. Okay, a lot of heat in the board right now. Okay, try to chill things out a bit. I need to figure out a better view for this. I have a lens coming for that hair camera, that junk camera. I'm gonna see if I can't. I want to see if I can't get it to work as maybe a new webcam. So, all right, I see a problem, and I'm just not. I'm gonna go ahead and fix it. And the problem that I see is I'm not happy. The chip's kind of on there crooked. This side really did not seat right. Let's fix a couple of things real quick. Let's kind of move that in a little bit. Let me move the microscope cam. There we go. Turn the fan off. Try not to stick the hot air gun up my nose, or the hot air wand up my nose. Take the brightness down just a little bit. Woo, not quite that much. Okay, good. Okay, I need to be able to see a little bit better than that. Okay. There we go. I like that. It's better. Okay. Hopefully the extra heat cycle didn't just destroy the chip. We'll see. Okay. Oh, gotta be careful with my good chips. They're up there just waiting for my attention. All right, let's see. What's the next one? So that one's replaced. Let's go to 50 to 19. 19 is right. Ooh. Let's put that on the cooler. Hang on a second. Let's go to overhead. All right, so I'm going to let that one cool. While that one's cooling, let's come over here to 52. That's just this one. Oh, sorry, off camera. Let me get it in place, and we'll get ready to take it off. Okay. Microscope cam again. There we go. So this is 52. This is one of the ones that we had a resistance problem with. So I'll turn. Just going to turn the fan down because I want to take the heat out of the other side of the board while we're working on this side of the board. Judging from the dirtiness of the flux bubbling up, I don't think I've pulled this chip before. Ooh. Ick. Okay. Go ahead and put the... That is ugly dirty. Okay. When they're that bad, I am going to go ahead and clean up a bit. So, turn the fan on high. Let me slide that over to get some. There we go. Okay. I just moved the board so the fan would actually be taking heat back out of the board. Meanwhile, okay. Okay, that's better. All right, let's put a little bit of flux on there. Cleanup time. Does look like the solder looks like it was probably replaced at some point. Maybe I did it and I just didn't clean the maybe I just didn't clean the flux before. Sadly, I had a batch of used chips that I did not test properly, and so I think I ended up installing a series of bad chips on boards, or weak chips on boards. Now my testing process has gotten better. Uh-oh. Hold on. Oh dear. What I'm looking at through the microscope is, did I just bump off a... I don't think I took a... I don't think I took... Words, Brian, words. Right here, R211. I don't think it's supposed to have a resistor, because the way that glob looks, I think I just suck the solder right there. But let me go check it real quick. I do not have my screen set up for that. My apologies. I have a cheat sheet that I made in Excel. I'm sorry, in Google Sheets. And anybody that's watching it right now, 140, you could say, hey, I want that sheet, and I would send it to you. But no one's watching right now. Too bad, so sad. Okay, 211 is does not have a resistor, so that's okay. Cool. All right, let's go ahead now. Let's clean up again. So when I got into doing repair on these boards, wasn't that long ago. But there was so much information, like there were constantly, I could watch new videos almost every single day. Now nobody's repairing these boards. The weird part is I don't see like S19 boards, I don't see hashboard repairs going on right now. So did everybody go like underground secret? I don't know. It's crazy. I need to fix my focus. There's a little bit of a problem with my cable, my USB cable. It's so stiff that it creates about a 1 millimeter rise over time in the focus tube. And that's what's mess. That's why the focus goes out of whack every once in a while. My apologies for that. I will get it fixed. Just not right this second, because I want a hashboard working. Crazy thing is, when I fix this this like problem where we get that temp sensor issue, once I figure out exactly what's causing that and I fix it, which come on the trail. Once I do that, then I have 3 boards that I'll do the exact same fix to, and we'll have a complete miner running and hashing. That is exciting. Okay, cool. Got that. I'm good. Ready to go. Let's slide the keyboard back under there. Okay. Slide that there. Get that over here. Turn that off. And let's get to it. Oh my gosh, what time is it? I've been live for an hour, and what have I done? I've done 2 chips. I promise I'll get better. So I'll give you the hint, or I'll give you the answer to the thumbnail, right? Is this board hopeless? I don't think so. I don't think this board is hopeless at all. I think that I just need to refine my testing process, and which I'm doing, and I'm sharing the progress with you guys. I think I just need to learn how to better identify some of these chip problems, which I'm doing, and then this board will be a winner. I can tell you one thing for sure, I got too much flux under there. Causes the chip to float too much. Okay. See, I get those bubbles coming up from the other side. Like the demon from undersea. Okay, I think I finally got it settled down. There we go. I like the placement. Just want to see the little shiny silver. See, this is a very dirty one, so I think probably I've replaced it before. But I probably needed to flip it upside down and clean it out. Okay, there we go. Turn on the heat. Or turn on the fan. Let's cool this thing off. A little bit of pressure. Not much. Okay. Good. All right. While we are at it, let's take out, so that was 52. Replaced. Okay. I want to go after 65 because that one has that when the 65th chip is wacky, it can cause problems. So we'll turn down the heat of the fan, cooling fans just a little bit so I can get 65 off. This will be the last chip we do, and then it's not all the chips, right? I've got plenty of chips that still need to be pulled, but I want to see what's going to happen when we get these chips out of the way, because these chips all have a certain issue, I think. I think they're key chips that are causing our problems. By the way, you can, if you can get a board hashing and you're using like Banish firmware or Brains firmware, Brains, not Brain, Brains firmware, you can actually identify weak chips because it'll show you which chips are not performing well. And you can certainly, sorry about the focus there. Again, gotta get this camera. Let's see if I can let's fix it real quick because it just keeps causing me grief. Anyway, let's see if I can talk and work at the same time. So you can, with Banish or Brains, you can actually, it'll identify which chips are not performing up to par, which chips the computer has said, or the controller has said, hey, don't set it quite so high. And so you can then take those chips out, replace those chips, and then you'll get a better performing board or longer lasting board. So you're not having to sit there with the meter and sort it out. But once you get it on the bench and it's all disassembled, it's not so easy to throw it in. I will once I get this board hashing again, I'll have one more cycle where I pull it out and replace any chips that Banish tells me is weak. Although I'll bet if I get all of the high resistance chips out of the way, I bet I don't have any. But we will see. We will see. That is for sure. Okay, kind of a dirty work area there. Let's clean that up. By the way, I'd really like to see that solder right there on the nut. I'd like to see that flow a little bit better. So we'll put some extra flux there when I go to heat things back up. Okay, let's retin the. Let's go ahead and retin it. A little bit of solder. Okay, fine. We're done with a little bit of solder. I'm going to get a big piece of solder. Oh, there it is. I'm going to use this thing all the way up. This is like squeezing the toothpaste to the point that it just, you can't squeeze and press anymore. Look at that. That's all the solder I've got left of this little piece that I have. So I'm getting every last little bit out of it. Cool. Cool. See that one? Let's see right here. See how the trace goes straight into the actual negative pad of the chip. So you need that solder mask right there. Otherwise, your solder will flow in and won't get a good connection there. All right. Last chip. Here we go. Let's put down there. Which one are we going to use? We'll use whichever one actually wants to be nice and participate. There we go. I like that one. Okay, let's turn the heat off for this part. Or, I'm sorry, turn the cooling fan off for this part. Bubble, bubble. Here we go. The craziest thing is that it seemed like to me earlier the brightness was just right, but now the brightness is all kinds of wonky. I've got the auto white balance turned off. I don't understand. Oh, nice. Look at that. It's a 1397 AD chip. Worked fine on the S17s. In fact, I believe that that's the actual chip that came on most of these boards to begin with from the factory. Okay, there we go. I don't know what it is about the 65th chip, but it's always a difficult one for me to solder. I don't get the little pretty little solder balls on both sides, on the contacts, not the extra solder balls, just the ones that are supposed to be there. All right. Now let's go see microscope cam. Oh, heck, there's part of the problem. The white balance was set to auto, and that is why, and so is the exposure. Why are those changing on me? There. Now it's not so blown out. Honestly, I don't understand. Okay. Set that to the side, put this into that. Go to the overhead mode. Go to the overhead mode. Come on. There we go. Good, good, good. Got the overhead mode in full effect. All right, we're just letting that cool down. So that was 65 that we replaced. So replace 3 chips this hour. Yay me. Okay, much better. All right, so let's find out now. Let's go to tester mode. Okay, before we do that, since it doesn't want to switch, let's check the chips we replaced. So we replaced 52. Let's check our resistance. That's down in the bottom right. Oh no, it's still a high resistance chip. So I'll probably have to replace it again. All right, 213. It's out of spec. So I'll do that one. Let's check. Ah, good. Okay, 65 now is well in spec. Okay, so that one's okay. And the other one I replaced was 6. So let's find out how 6 did. Oops. 116. Okay, so that that was okay. That was 5. Okay, good. 76. So now 6 is in spec. 65 is in spec. 52 not so much in spec. It's still got problems. Right, see that? So I'm gonna have to replace it again. Oh, okay, there we go. I just didn't have a good connection. Awesome. 119. So we got three. Now this is one of those chips that I think maybe it had been treated by the vendor, and so some parts of the chip don't get a good bit of continuity. But if you get over on the corners, you should get the right value. Okay, cool. Whoa, 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 whoa. That was kiloohms. Killer. Let me put the pokey on here. And I can't even insert a stupid test probe. There we go. Yeah, what you don't see on the screen, I've actually got 124 kiloohms. 79 ohms, right? But right here, I've got kiloohms. That's a problem. That's a bad problem. Okay, so I'm going to write that one down. What was that? 124 kiloohms. Yeah, 126K. 126K. All right, so I'm going to have to replace that one again. But let's just test and see where we are. Maybe we're somewhere. Maybe we're making progress. So let's do that. Flip over to the tester mode here. If it wants to switch for me. Come on. There we go. It finally wanted to switch. All right. Everything's cool. Let's just run a quick check and see, do we have 65 chips? Yay, we have 65 chips. Cool. Let's get our thermal cam going. Shocker of shockers, I've got to turn everything back on. This is why I want one of those thermal imaging units that are dedicated to thermal imaging. All right, cool. Now hopefully, oh, good, it still works. Okay. Clearly the picture color is wrong, but okay, there we go. All right, we're gonna run temperature and let's see what we get. All right. So, ooh, look at that. We got 15 under control. We don't quite have as much heat going on. Ooh. We do have some, oh, maybe not quite so much shenanigans there. Okay, definitely made some improvements there. We still have issues right here. What is this? Oh, that's 19. I haven't replaced 19 yet. Okay. We're getting hot. Okay, it looks like 2 now. Temperature sensor 2 is really taking off with the heat. Maybe not that bad. Honestly, just that bottom row there, we're getting some warmth. Nothing here. Now, we don't have any issues with... Okay, so let's turn that off. And let's run let's stop testing real quick. Okay. Let that cool for a second. Still have some heat registering here, so something is not quite right. But I'll keep working on that. What I want to do right now, though, is I want to see if we actually changed our signal any at all, right? So let's do it. We're going to test. Let's go. We'll stay here because you can see the top. So I'm going to test CI. CI is the second pin there. Okay, CI is good there. CI is good here. CI is good here. So far, so good. Nothing different. CI is good there. Come on, the next one's a big one. No. And we get to still the funny business about when you touch CI, it freaks out. Tells me that 50 is not good. Now it's just jumping all over the place, right? Okay, so we still have that. Still have the CI problem there. My guess is CI is probably good here. No. Stop it. Test it again. I want to see if where CI fails. So CI is no good there. CI is good there, but no good here. Right? Okay. Yeah. Dang it. So we still have the CI problem. All right. What about the RO problem? So if I go to RO testing here. Got 35, 45, 55 starts freaking things out. 45. Oops. Should be 46. Let's go to here. 50. 51. 52. 53. But there's where we start getting into some funny business. Things get weak. But if I go back here, it's solid, right? Here it gets to be funny business. Here, still funny business. And then here, we're just like crazy, right? So there's definitely some signal flow problems in that domain. But it doesn't look like we have. So the signal problems of this third domain here. Okay, yeah. But like I can't come over here and start here with the first chip. It tells me 0. In fact, this whole domain 13, if I touch the RO port on that domain, it wipes out chips. In fact, does that to me until we get to, so 1, 2, yeah, so oh, it shut off. Okay. Okay. All right. So essentially, this this half of the board is flaky. The RO testing doesn't work, so I've got some stuff to do. But we've been on this stream long enough. Thank you for watching. I still don't think the hash board is hopeless, and I'm going to get to the bottom of it. I think I'm going to go take a break, and then I'm going to replace chip 52 because I'm going to check the resistors, make sure all the resistors are in place, make sure nothing's missing there. But 126 kiloohms when it should be less than 200 ohms, that is definitely a problem. Thanks for watching. Have a great day. And remember to smash that like button if you enjoy this content and you'd like to see more of it. Don't forget to hit the subscribe and the notification bell so you'll be notified when I go live and put out future videos. Thanks again for watching and have yourself a wonderful day.